Hello everybody, and welcome to this introduction to InfoDrainage, which is aimed very much at existing microdrainage users. So some prior knowledge is assumed, and whether you are considering or in the process of upgrading from microdrainage to InfoDrainage, I hope that this presentation convinces you what a upgrade that is, what a simple product and what a much more intuitive product InfoDrainage is in comparison with microdrainage. And I wanted to start on that point and explain there's several ways in which we hope that InfoDrainage is easier to understand. Let's start by looking at microdrainage and the modules within it. So I'll just bring up microdrainage. Here we see a typical model in plan view, and when you first open microdrainage, you're often presented with this module selector. And you can see this is a wide list of different modules that have built up over the many years that we've been developing microdrainage. Now in InfoDrainage, this is a lot more simple. There is just two versions of InfoDrainage. There is what we call the standard version and what we call the ultimate version. And that's at the time that I've recorded this presentation. In the future, who knows, we may well bring it down to one version, make it even simpler than that. But at the moment, there's two. So looking at these modules within microdrainage, we have the cost module, the costing module. We've done away with that entirely. It may come back in the future, but at the moment it doesn't exist within InfoDrainage. We also have these two, channel and pluvius. Now, I've worked on the InnoVise support team for a long time, 8 or so years. I can't say I've ever used channel or pluvius. I don't know what they do. So we've also done away with those. Whatever they did, they no longer exist within InfoDrainage. We also have some CASDEF functionality within InfoDrainage, but that's not exactly the same. And again, personally, I was never really a fan of CASDEF. I don't see that it provided much that you couldn't do in a more streamlined, intuitive way. So we hope that the workflows that we've put into InfoDrainage cover that. But apart from those four, everything else that used to exist within microdrainage exists within InfoDrainage. And as I say, just as two versions, either the standard or the ultimate version. Now there's two main differences in InfoDrainage between the standard version and the ultimate version. There's two modules which exist in the ultimate but not in the standard. The first one is the DrawNet module. That's the links between InfoDrainage and Civil 3D. The second one is the FloodFlow module. So that's the designing for exceedance, the overland 2D FloodFlow routing. That also doesn't exist in the standard version. It only exists in the ultimate version. So yeah, it's those two modules and your choice over which license you have. So I guess one of the main questions we get asked is why InfoDrainage? You know, why do we have this new piece of software that is replacing microdrainage? Well, there's a variety of reasons. The first is a new interface. Now, I have to confess I really like microdrainage. You know, I've used it for a number of years. I find the workflows in it are great. You know, if you're designing pipes, designing storage, designing SuDS, doing flood flows for exceedance, that type of thing, it has a very nice linear workflow to that. And we wanted to retain that in InfoDrainage. But even the most ardent fan of microdrainage must see that it's now over 30 years old, and some of it does look like it was developed in the 80s and 90s where it had its starting point. So it was really time for a new interface. So let's look at that new interface. Here we go. Here is InfoDrainage. And the first thing I'm going to do is I'm going to import that microdrainage file that we were just looking at. So here we go, we import from the import dialog box here. I'm not going to save my previous data. And then I go away and have to find the file. So it's asking me for a name. I'm just going to call it test1. Now, when we do the import, there are just a couple of things which used to exist within microdrainage which don't exist within InfoDrainage. We've done away with the concept of maximum rainfall. There's also a very slight change in our representation of foul networks. But anything like that, anything that exists in that particular microdrainage model that won't be directly imported, you get this warning message. So very, very minor. They're worth looking at, but very, very minor differences. And then when you're happy, press OK, and it goes away and it brings in the network. And you'll see it looks identical pretty much to how it looked in microdrainage. Now, as I say, we have got this new interface that we're looking at here. We hope that it's more modern, looks like many other software packages, in that it has a list of different dialogues across the top here. If you click on any of them, you get a series of sub-menus below them, buttons to press on. Some of them will be grayed out. They may not be appropriate. For example, I haven't run a simulation with this model yet, and therefore I can't look at the results. So we've tried to be, as I said, intuitive, tried to think about the order in which you're doing things and making those buttons in a sensible order to accommodate that. So that's the top menu and the plan view. Over on the left hand side here, we have what's called the tree view. Now this is where essentially we manage all the data. So we can see here everything is listed as a separate item. So again, you may remember in microdrainage, it was all about the pipes. You know, we listed all the pipes, and then everything else kind of hung off of that. So we would have a subcatchment associated with the pipes. You would then look at the manhole table associated with the pipes. In InfoDrainage, we've taken a different view. We have these separate items. So we have the manholes separately. We can list them. We can click on any manhole, and you can see it appear there in the plan view. We have the connections or the pipes. A connection would be a pipe or an open channel or a variety of other things. We have the inflows, and as you can see here, there's 28 of those. So that's all managed. We can rename things. We can change how they're displayed, you know, the thematic coloring of them. If we create something, it would add to this list. It's all managed from this tree view. One of the other things that we do here is if we wanted to import some background CAD data, we would do it via this dialog. Just right click there and import it. If we wanted to import some surface data, again, the same principle, just right click on something and you'll always have that functionality, hopefully what you're expecting. You know, if you wanted to load something in, it would prompt you to do that. So this dialog is also used for importing information. The other thing that we do here is this phase management. And again, this replicates functionality that existed within microdrainage. So we have the ability to have several different versions of the same design within the same file. And we can choose from this dialog whether they're displayed, whether we're going to use them in simulation. So you can see this one is shown in green. If I switch it off, it wouldn't be used in simulation. If I click the light bulb, if there was more than one of these, we could choose which ones we were and weren't displaying. Obviously, with only one, it's obvious that you do want to see it. So that's a tree view, essentially where we manage everything. Now over on the right hand side, we have the toolbox, and this is used primarily when we want to create things. So for example, if I wanted to create a new manhole, it's under the junctions list here. You just take the manhole and place it wherever you want to place it. We would then perhaps take a connection, take a pipe, connect it from the manhole down to wherever it's going to be connected. So say down to that one. Then we might digitize a subcatchment. So that would be an inflow. I'm just going to check under the import menu, under the plan menu, that the snap is switched on. Yep. So I drag out a catchment area, place it where I want to, and then I can digitize it, snapping to perhaps some existing vertices of other subcatchments, and then right click to close it. And you can see that it's automatically associated it with this manhole. Now, if I wanted to instead attach it to a different manhole, that's very easy. One of the complaints about microdrainage was that it was very difficult to do that there. If you wanted to do it, you essentially had to delete the subcatchment and start again. But now it's very easy. Just right click on it and reconnect this inflow. and then place it wherever else it is that you want to place it there. If we want to edit something, again, very easy. We could click on an item and then just drag out these vertices, and it's all linked together. So if we then wanted to look at the properties of any item, so we'll start with this subcatchment again, double click on that, and it brings up its area. Now, if we were to redigitize this area, it would obviously update this value. We can also, from this view, edit any other characteristic that we choose. For example, the volumetric runoff coefficient, we could edit directly in here. And that applies to any item. So similarly, we can click on a manhole. Oops, I've clicked on another subject catchment there. Click on a manhole, and it brings up its properties. So if you wanted to edit its easting and northing, or copy this data in from somewhere else, then you could do that there. Very simple. So that's the principle, is that all these items exist as separate objects. You create them from the toolbox. They then become listed in the tree view, and you can then do what you like with them from there, edit them, go from there. Now, there is several different ways of looking at this data. One of them would be the tables in tabular form. So if I go to the build menu, I can open these tables. And I have to say, at the moment, this dialog box is a bit over-designed. It's probably a bit complicated. We intend to look at it and hopefully simplify this in the future. But at the moment, you first pick the tab, the item that you're interested in. For example, here is the junctions or manholes. And we can see that this, it looks a bit like a table, Excel table, and it does act like it as well. We could take this data and copy it out to Excel, or we could copy it in from Excel, anything like that. We can, there's some manipulation buttons here. If we wanted to add, add a meter to certain cover levels, you could do it like that. But so these tables do look and act like you'd expect them to, and you can copy and change data within them as you would hope. Now, another way of looking at the data is in long sectional profile view. And here we introduce the concept of flow paths. Now, flow paths are very useful. Firstly, they allow us to create these long sections, but also they're an extremely useful check. Now, with InfoDrainage, there's no limit to the way in which a network can be connected up. In Microdrainage, it had this very specific numbering system. So that doesn't exist anymore. You have complete freedom to connect things up in any way you like. But what that does mean is that you need to make sure that it's connected up correctly. So for example, I may assume that this manhole right up here at the top of the catchment is connected right down to this outfall here. To be sure of that, then I would create a flow path. And if it does correctly connect these pipes and manholes together, then it will show that. If you couldn't create this this red line that we'd see, it would be an indication that you've got a pipe missing somewhere, or a manhole that's not connected or something like that. So it's a very useful check kind of in and of itself, but also it's our gateway to creating these long sectional profile views. So once you've created a flow path, just right click on it and go into the show profile. Now, again, I'll say I was a fan of Microdrainage, but if you remember the long sections, they were really the oldest part and looked like they were at least 30 or so years old. We hope that this is a much more modern way of looking at the information in plan view, in profile view or long section view. You've got the manholes there with the cover levels. You've got the invert and soffits of the pipes. We can see the little pink line there is the minimum cover. So these pipes look like they need to be placed deeper in the ground at the moment. But then below that we have the tabular associated information, and you can customize what appears in these tables. So when we imported the network information, we also imported the rainfall information. So going back to Microdrainage, and again, on the assumption that most of people watching this video will be experts in microdrainage, you should know that there are 3 different places in which we store rainfall data in microdrainage. Firstly, there's the rainfall that we use in the design of the pipes. So when we go into the design criteria, we can see it here, and this would typically be a 2-year, 1-year, 5-year storm. But this is the rainfall that's used in the automatic process that calculates the size and the gradients of pipes. So that's one form of rainfall. Second form of rainfall would be under the simulation criteria. So if we were going to run a single storm, if we just hit the go button to run the rainfall through this network, it would be this storm, a 5-year return period, 30-minute duration, summer storm in this example. So that's the second type. And the third type would be the seasonal return period wizard. So this would be the range of storms of different durations and possibly different return periods as well that we use to run our critical storm analysis. Now those 3 types now have been imported as part of our import into InfoDrainage. So if we look at the rainfall and pollutants and go into the rainfall manager, we can see that there's the 3 types there: the design criteria, the simulation criteria, that single storm, and then the seasonal return period wizard. So looking at the design criteria first, we can see that we have the option to choose summer and winter, and then we can our return period of 2 years is selected, and we've got the choice of storm duration. So in this case, I'm going to go with the default. So let's look at that first. I'm going to make sure that the others are switched off. So the seasonal return period wizard I'm going to switch off, and the simulation criteria, that single storm, I'm going to switch that off as well. And the next thing we're going to look at is the pipe designer within Microdrainage. So the way it worked in Microdrainage was that we would, here we go, just bring up Microdrainage, is that we would set up our network design criteria, and then we hit the magic optimize button. Now I know there's a lot of people who didn't like that optimize button, and I have to say we also found it infuriating sometimes, because you'd set up these rules, you would define them in the design criteria, you'd then press that magic optimize button, it would go away and optimize the network, and sometimes it would just break the rules. And even on training courses, it was sometimes difficult for us to justify how and why it was breaking these rules that we'd set up in the design criteria. So for those of you who basically don't like the design criteria within Microdrainage, I would say please sort of give us a second chance. Have a re-look at it within InfoDrainage, because we've had a re-look at it. We've thought about the rules, and we've tried to be much more rigorous about complying with those rules. And also, if we do break the rules, we've tried to be very careful to show you how and why we are breaking them. So let's now run through the network design wizard. Under preliminary sizing, go into the wizard, we choose the flow path. InfoDrainage designs one flow path at a time at the moment. Step through that, we've got our rainfall selected, we've got our criteria selected, and then it goes away and does the calculations. And anything that it's struggling with, it will highlight, as we see in this example here. So it gives you the choice. If you want to manually adjust it, then you can. You go through and press finish, and it gives you a table which is very similar to one that exists within Microdrainage, which quotes the capacity of this pipe of this diameter laid at this gradient, and compares it with the amount of flow that's calculated to go through it, so that we can see that the pipe has plenty of capacity in it in this case. We can also look at it in profile, so I could right click and go into show profile. It also appears in this button on the top menu here, so you show the profile and it goes through and it shows what's happening. Now in this case we can see a very steep catchment. These pipes were laid very deep because we needed to comply with the maximum velocity criteria. I imagine that was the overriding one in this case. If we'd allowed backdrops, then we could have perhaps seen these pipes being designed closer to the surface. So as I said, if you've used the Microdrainage Designer in the past, haven't liked it, then please give us another chance and look at InfoDrainage again, and we will be doing specific presentations around that. So the next stage, once you've designed your pipes, you would move on and run your simulations, design your storage structures or your SuDS structures. And at this point, I want to move to the next point in the why InfoDrainage. So as well as a new interface, we've introduced a new simulation engine. In other words, the way that we do those flow calculations, we've really completely started again. For those of you who are interested, the simulation engine that we use is the SWIM engine, SWMM. Now this is a really sophisticated, it's also a really popular engine. Lots of companies take it, adapt it to their own needs. We use it as an option within our InfoWorks ICM software, our advanced flood modeler software. So because of that, we thought we were setting ourselves up for the future, and the philosophy is that you would do your designs within InfoDrainage and then import those designs into InfoWorks ICM to look at the wider implications across large catchments, on the flooding that may be created by your new design. So it was all part of an integrated strategy of InfoDrainage and InfoWorks ICM. As well as that, you remember in Microdrainage, of course, if you added in a new pipe, there was this very specific numbering system that you had to comply with, and often you would add in a new pipe or a new branch, and it would then inevitably renumber everything downstream. Now in InfoDrainage, that limitation does not exist. As I said earlier, put it in any order you like, connect it up in any way you like, number it in any way you like. You have total flexibility there over the way that you control and design your systems. But also the other reason for doing this, the other reason that we did need to switch to a new engine, is that we wanted vastly increased representation of SuDS. We started on this with our MD SuDS module and the MD SuDS add-in to Microdrainage, but we've developed it a lot further. And I want to demonstrate that now. And I want to do that using a InfoDrainage model that's been prepared earlier. So it's this one. Now this is actually taken from our training data, and I'll talk more about that later. But here we have essentially a completed model. You'll see this one does have some surface data which I can switch off in the background, and it has some CAD data as a layer which I can also switch off. I zoom in by rotating the wheel on the mouse. That's one way of zooming in, and we can see that now we do have some inflows, the same inflows, which I can choose to switch on and off. But now we've got this this network that includes 3 SuDS structures, which are shown here. Actually, this is still looking a bit busy, so I'm going to switch off the labels here. So I can open anything. In this example, I'm going to open the junctions, go into the display settings. I'm going to turn off the junction labels. I'm also going to turn off the connections labels as well. Okay, it just looks a lot cleaner. And now you can see that we've got 3 different SuDS structures here. Now, one of the key differences between Microdrainage and InfoDrainage is that we represent structures as polygons. So you digitize them where they would exist in reality. And we can see the lengths of the pipes that connect up as well. They are the true length. So wherever your outlet orifice in this example would be, you could then have a connecting pipe. So in Microdrainage, you would have to manually alter the length of this pipe. Otherwise, it would be wrong because it would always be connected to a point in the middle of the structure. Now that we can work with polygons, we can have a much truer representation both of the shape of the structure, but also of the lengths of the pipes that connect to it. It should always be true lengths now. But I was talking about the simulation engine, and one of the reasons that we had to use it was our vastly increased representation of SuDS structures. And a good example of that is this swale. If we click on the swale, we bring up its properties. You'll notice there is a pollution associated with this. We'll do separate presentations around pollution. I won't talk in detail about it today, but we have started to represent pollution within InfoDrainage. But today we're looking at the representation, the physical representation of this swale. And to help you, each substructure will have a picture associated with it, so that you can relate the parameters that you're being asked for to, what we think they represent in reality. But the reason I'm using this picture is because we can see with the swale in particular, there's 3 flow routes through this swale. We can have flow through the open grassy channel at the top. We can have flow through the gravel-filled trench that's underneath it, and in some cases there would be pipes within the trench itself, and you can have flow through those pipes. So we've got open channel flow, we've got gravel flow, and we've got pipe flow, all existing within the same structure. Very complicated mechanism, and you can have water moving between these along the length of the structure. So as the gravel-filled trench fills up, water would start to then fill the channel. So this is really a lot going on here. 3 different flow rates through 3 different media, and water moving between each media as we move along the length of the structure. So microdrainage would represent this by having an amalgamated roughness, which represented the entire structure. In InfoDrainage, we truly represent the 3 different flows going through the structure. So whilst we're here, I said at the start I would describe how source control, we still have source control within InfoDrainage. So there's 2 aspects, I think, 2 main aspects to source control. If I can remember where it is. Here we go. Under preliminary sizing, we have these quick storage estimates that you used to get in source control, and we also have the rural runoff calculators. So those are the 2 principal features. There is one other thing that was a very nice feature of source control. If we clicked on any, or if we were designing a particular structure, we could get a preliminary size, a quick storage estimate. That's been incorporated into this sizing calculator that exists for each structure. So if you go in there, this one's been completed, but you can calculate the volume based on a quick storage estimate or a variety of other mechanisms. But we hope through those 3 things we have incorporated all of the functionality that used to exist within source control. So the structures that you design don't need to be as complex or as integrated as this. If you just wanted to design just one structure like you used to in source control, just do that. Just digitize the boundary of the structure, put in its dimensions, use the quick storage estimate, give it an outlet, and away you go. It's as simple as that. So it's all contained within this same interface. So we've now created our pipes, manholes, structures, everything, and we want to go and do the analysis. So it's done from this analysis drop-down. And the first thing you do is you set up your analysis criteria. Now this looks completely different to the seasonal return period wizard. What we're doing here is you set the output interval. So in other words, how often do you want the results? You get to choose the time step, default, reduced or shortest. I would usually go for shortest. In microdrainage, those of you who've used it for a long time will know that we sometimes used to run up against instabilities. Instabilities still exist within InfoDrainage. They exist within all hydraulic software modeling packages. We hope that the simulation engine is more flexible, more robust, but it does bring us on to a subject that I know is of concern to a lot of people who are thinking of upgrading. If you take your microdrainage simulations and bring them into InfoDrainage and simulate them there, will you get the same answers? And the answer is probably not. The answers are likely to be similar, but they are unlikely to be identical because they're 2 different software packages using 2 different simulation engines. And the thing to, I guess, emphasize here is it's not as if one's right and one's wrong. They are just 2 predictions of what we hope is replicating reality. So an analogy that I would use is something like a weather forecast. 2 different weather forecasters might give you different forecasts. It doesn't mean that one's right or one's wrong. In some cases they'll be very similar. In some cases they may be further apart. And it's the same here. We've written papers about how and why simulation results would be different. But as a sort of headline, I would say that the general philosophy would be is that if you are working on an existing project within Microdrainage, then I would carry on and finish that project within Microdrainage. But if you're coming to start a new project, then I would certainly recommend that that's the time to switch to InfoDrainage and start using that. Because yeah, inevitably we do get different answers. So we set up our analysis criteria as shown here. And a very useful feature that we've got now is we've got this validate button. Now this just checks that everything is sensible. You know, does every manhole have a cover level? Does every pipe have a diameter? Click on that. Now I won't go into this in detail, but this is an extremely useful feature. If there was any problems here, they would be listed in this dialog, and all you would have to do is click on them and they would take you directly to the relevant place. So for example, if there was a problem with a manhole, or let's say there's a problem with a pipe, it would open up the pipes table and it would highlight the particular pipe where the problem was. So it has to pass this validation before you're allowed to run the simulation. So in this particular case, we're going to be running 18 storms through this fairly large network. I think we could see there was 43 pipes in here at the shortest time step possible. I'll run this in real time, so we'll hit go. I'm not reducing the time of this at all. Here we go. So run through that and you can see the sort of time that it takes. Now I'll be honest, it does take slightly longer, not much longer, but in general it'll take slightly longer than your microdrainage calculations. And we think that the trade-off is acceptable for, as I say, the increased flexibility, robustness that brings. Now, when the simulations have finished, you can see that they're presented here. Now, what it's presenting by default is a summary of the 3 storage structures. I'm just going to close that for now, and then we can reopen it. If we go to the results menu, we can see the summaries for our inflows, junctions, stormwater controls, and connections, and we can also use the graphs. So I may start by looking at a summary of the stormwater controls. And this concept of critical storm and making sure that your design works for all storms is of course retained within InfoDrainage. So at the moment we can see that for this particular storm, which is the 30-year 15-minute summer storm, in the 3 substructures we have 62% storage available, 52% and 54%. If I wanted to look at a different event, I would just choose it from this menu and those numbers would be updated. But of course, what we want to do most of the time is look at the worst storm. So we've got this critical storm button. Click on that and it brings up, it tells you which was the worst storm. So for our 3 substructures, it was the 480-minute winter for that one and the 240-minute winter for the other 2. And then over on the right hand side, we can see the percentage available. So because this is some pre-prepared data, because we've been working on it, it is perfectly optimized. You can see there is just a small percentage available, and that's below the freeboard level. We'll very quickly have a look at some graphs as well. So if I look at the stormwater control, let's look at the pond. We have, I won't go into the details, but essentially we've got the inflows, the outflows, the rainfall, the volume, things like that. And again, we can choose which particular storm we're interested in from this dialog here. So all your graphing is available to you. Okay, one other topic that I wanted to move on to was going back to talking about how we build models, because you saw the tables and how we can copy data into those. That would be one way of building these models. You're not limited to the row by row building of a model that you were in Microdrainage. But we've also really extensively improved the import of data. So if I go to the import tab, we can see that of course we can import data from old Microdrainage files, we can bring in data from LandXML, from CAD, from GIS, or from text files. So they would be imported into these dialogues here on the left and they would appear here. So just to give an example, what can we do? So as an example, I'm going to import some inflows from GIS data, and this is taken from our training data again. So I choose what type of file I want, go away and select it, pick the file, comes in, shows me what it's going to import, press next, choose what type, and I get through to this dialog box here. I'm not going to go into the details of this, but essentially on the left it presents what InfoDrainage is looking for in terms of, you know, the volumetric runoff coefficient, that kind of thing. And on the right here, it lists what that file can provide. And essentially you marry up what you need in InfoDrainage with what you have from your source data, in this case, a GIS file. You match the two up, press the import, and it brings them in. So when you're building a model, not all of the data has to come from the same source. You can have some from Civil 3D, some from GIS, maybe some from a text file. Works like that. I won't go into the details of that today. What I really wanted to look at was the primary feature of InfoDrainage, which is its interaction with Civil 3D. Okay, so we can go back to the PowerPoint presentation for this. So we've got these enhanced import-export capabilities. So the way it works, I'll run a pre-prepared video. This is looking at Civil 3D, and now within Civil 3D we've got this dialog box which you just saw. It sits, you'll see we've got this InfoDrainage ribbon which sits within Civil 3D, and those import and export dialog boxes which you can see there grayed out in the top left hand corner. So we're running through that, and the first thing you need to do is go away and select the file that you want to export, because we're exporting out to InfoDrainage here. Pick which part of Civil 3D, which layer within Civil 3D you're going to export. Now here we get into this dialog box where you are saying what exists within Civil 3D and how do you want it to appear within InfoDrainage once it's exported. Now the pace of development is so fast that things have moved on even since this video was prepared. We now have intelligent parts mapping. So if you've got a part within Civil 3D, say you've got a 375 pipe, it's likely to make a good guess and assume that you want to export a 375 millimeter pipe when you come out to InfoDrainage. However, if it doesn't make that connection, it's intelligent, but it's not perfect. So if it doesn't make that connection, it allows you to either type in those values yourself, or once you've done them once, you can save those connections in a file, load in that file, and it will automatically do those associations. So at the very worst, you'll have to make these associations once and then save it in the file. But most of the time, it should work it out for you. And the same principle applies to the pipes and to the manholes. So it goes away, it does those, and it then exports out to InfoDrainage. So let's look now at coming back in from InfoDrainage back into Civil 3D. Very similar process. You go to the InfoDrainage ribbon within Civil 3D. Just another thing just to mention at this point is you will know within Microdrainage there was two separate installers. You would have the main Microdrainage installation, but then you would also have the DrawNet installation, which was the addition to AutoCAD or to Civil 3D. Again, all of that is simpler. It does it automatically. If you install the ultimate version of InfoDrainage, as long as there is already the copy of Civil 3D installed on your machine, it should make that association. It should come up automatically. There's not a separate installer anymore. It's all done in one, which we hope is a lot simpler. Okay, but we're bringing back information now from InfoDrainage into Civil 3D, and again we do the either intelligent parts mapping or a file that we've already prepared, and it brings it in like this. And you can see it's brought the information back, including labels and things like that you may need. Now this is just another view. This happens to be the 3D view. Now the point to make here is that things are rapidly developing all the time. We've got teams, InfoDrainage teams, Civil 3D teams working to enhance this all the time. But again, at the time of recording of this video, it's not completely there. What we've got is there is still some fields which exist within InfoDrainage for which there's no direct equivalent within Civil 3D. for example, the discharge coefficient of an orifice, or the porosity of one of those gravel trenches that exists within the swale that I showed. So for those things, there is no equivalent. You can't manipulate the data within Civil 3D. We hope that very soon everything will be fully mapped between the two packages. But for now, it is at least saved as metadata within Civil 3D. So for example, if you build your model in Civil 3D, take it out to InfoDrainage to do your hydraulic analysis, set up your orifice coefficients and your gravel porosities and all that kind of stuff. When you bring it back into Civil 3D, you won't necessarily be able to see it and manipulate it, but if you then did some edits within Civil 3D and go back again to InfoDrainage, all of that data would be retained. So Civil 3D remembers it all. It remembers all of the InfoDrainage information, and then next time you do the export, it is remembered and carried back to Civil 3D. One of the things we're just showing on the video here is that if you do an update in InfoDrainage, that is of course remembered and taken back to Civil 3D, and then those changes are taken back from Civil 3D to InfoDrainage again. So we have this complete round trip process. And in the early days, it used to be the case that you would have to delete the data from Civil 3D. That's no longer the case. It now does those updates. So if you move something, it updates it. It doesn't replace it, which is what we hope that you'd want to see. So that's a very brief introduction to the capabilities of going backwards and forwards between InfoDrainage and Civil 3D. There are several videos that deal specifically with that topic, and as I say, it is the major development consideration for us. Let's look now at the FloodFlow type module, the overland 2D flow routing, and there's two aspects to that. Firstly, there's what many of you will remember as Deluge, and as we can see here, what we're doing is with the Deluge module, we are simply, I say simply, but we are dropping a very large amount of rainfall, in this case 50 millimeters, onto the catchment surface. Now this takes no consideration of the built environment. The idea is that we do this as a preliminary assessment, and it helps us inform our decisions about where we're going to build our infrastructure. So if I just play it through here, we've got a 2-meter grid size. We're going to drop 50 millimeters of rainfall onto the catchment surface. We're going to be guided purely by the topography of the catchment. We let it run across the catchment surface and accumulate where we hope or expect that it would do in reality. We can then customize these thematic displays. For example, we're not interested in very, very shallow water. We're only interested in significant accumulations of the flow. Choose our color scheme, and then it gets displayed as we like. So this would be an example where you can see the areas of blue. These would obviously be good places to build our SuDS features, as this is where water is going to accumulate naturally, and it's probably not a good place to build our structures. So this is an initial guide that helps inform our decisions about how we are going to develop a catchment. The second phase of it comes at the end of the project, or towards the end of the project, where we have designed our below ground infrastructure, our SuDS features, our pipes, our manholes, and we want to see how that's going to operate during a very severe storm. So we can see we've got two views of the same simulation here, the 3D view and the plan view. And what is super significant about this is that it goes back to our representation of SuDS features as polygons rather than points, and it floods sort of correctly from the correct side of a particular SuDS feature. And you can see it flowing across the catchment. The representation is very similar to FloodFlow. The underlying mathematics are different. They're also updated to give us greater flexibility, greater opportunity in the future for how we may want to develop this module. But we think it's a great representation as it exists at the moment. Okay, so those are the two features that you get with the ultimate package that's not in the standard. The links to Civil 3D and the FloodFlow overland flow routing. Okay, a few other features that we have. Again, these are similar to functionality which existed within Microdrainage. We have this audit reporting. Now, we looked earlier at validation about how we need to make sure that the data is sensible before we run a simulation. This audit report takes that further. You can set limits, tolerances on various parameters. You can let it find pipes which are too long or too short, depending on what parameters you set. You set up these limits, you perform the audit, and then it picks out an audit report and tells you, you can see over on the left here, we've got some green ticks and some red crosses. It tells you which ones are acceptable and not acceptable. And just like the audit report, as we can see there, if something isn't acceptable, you can click on it and it takes you directly to that item within the InfoDrainage database, so it makes it very easy to correct. So some of the things we do here is if we want to correct something, as you saw there, we just wanted to make some manholes bigger, so we would just tick those boxes and let the software apply the limits and update the data in that way. We've also got the customizable report outputs. Again, we recognize that not everybody who audits a microdrainage model would necessarily use microdrainage, and in the same way we wanted the ability to produce printed outputs so that you could produce them and pass them on to the approving authority. So the look of these reports are quite different. You can see the microdrainage logo obviously doesn't appear anymore. We've got the InfoDrainage logo, but the data that they contain is the same, and it's customizable in the same way. We can look at, for example, what simulation criteria we used. We can look at which manholes flood, all that kind of stuff that you would expect. One nice additional feature that we're showing here is we've got the manhole schedules, including the schematics, showing the angle that the pipes enter and leave the manholes there. So we've got what we hope is, the graphs that we always had. So we hope that we've got the same much loved InfoDrainage output reports. Okay, so that I hope is a very quick run through of all the functionality, or most of the functionality that exists within InfoDrainage. How are you going to learn it? How are you going to bring yourselves up to speed? Well, we have revolutionized the way that we provide training. We used to provide all of our training in person. Now we have moved almost completely to on-demand training, and it's free. So we have now a dedicated web page where you can go. You can download the entire thing, or you can download particular modules, but there are a series of videos, not voiced by me, I hasten to add. We've got a professional voiceover person in to create them. So we've got videos, we have all the data, we've got the instructions. Hopefully there is everything you need to take yourselves through the InfoDrainage training course. We are looking at producing this in different languages. Which modules you complete is recorded and should be available very soon. Again, things are moving so fast, but at the time of recording the video, you couldn't produce your own certificates. I hope that by the time you're watching this, that sort of thing, you'll be able to see how many modules you've completed and get a certificate at the end. We certainly intend to have that, but it's meant to be completely self-contained. Already we've had well over 1,000 people who've gone through this. We haven't had any complaints so far. We hope that it allows you for free to bring yourself fully up to speed with InfoDrainage. Finally, talking about how do we get support. We're still here and available to you. We are integrating into Autodesk as we speak. Innovise is now fully wholly owned part of Autodesk. We are Autodesk employees, and we are changing the way that our support services work. So currently we are running two systems. We have the Autodesk support services. So if you're used to using Civil 3D support, for example, the vast Autodesk network of support, you can continue to use that also for InfoDrainage. So you would go in, select your product, this time pick InfoDrainage, and get your support in exactly the same way that you would get it for other Autodesk products. But the For Microdrainage, we've retained the support and Innovise, and it's important to say behind the scenes we have the same experts. You know, it's the same group of people who are used to dealing with on Microdrainage. As a team, we've transitioned to Autodesk and the Autodesk support services. One thing that it is important is that for licensing inquiries, it's very likely that you're using Autodesk licensing to run InfoDrainage. If that's the case, then unfortunately Innovise can't help with that. You have to go through the Autodesk support services. So the main piece of advice is, if you're a new user of InfoDrainage, if it is licensed through the Autodesk process, you know, the named user licensing, then get your support through Autodesk support services. That email address that we see on there on the screen for Microdrainage, that's likely to be going away at some point. It's not yet, but it's likely to be going away at some point. So engage with the Autodesk support services. Thank you for joining us.